Hello. Today we're going to talk about forces acting in mechanics to move a crate. And we're going to do it by pulling on a rope. And we're going to do it in such a way that we allow the forces to solve the problem by dividing the problem up into more than one dimension. We'll use an X dimension and a Y dimension. The boy drags a wooden crate with 20 kilogram, a distance of 12 meters across a rough floor at the constant speed of 1.5 meters per second. That means there's no acceleration. There is no acceleration in that direction. And there's also no acceleration up and down because the box is going to sit on the floor. It's not going to fall through the floor, and it's not going to be raised above the floor. A rope tied to the crate with a force of 50 newtons makes an angle of 25 degrees with the horizontal. So from that, you should be able to find all of these different things. And I'm going to show you now how to set up the problem so that you can get to all of those. Let's go to board one. In board one, you see our student here pulling on his rope. And the rope provides a tension of 50 newtons. There's one component that can be considered the Y component of that force, and another component that is the X component of that force. And we know that there's also an X component of the force of friction pulling back on the rope and on the student. In the Y direction, we have the weight pulling down. We have this tension pulling up a little bit. That makes the normal not equal to the weight, which is different than some problems because when you have the no angle here, an angle of 0, then you have the weight and the normal being the same. So what's the whole purpose of this? I can divide it into two equations. F of x equals t cosine of theta, that's the tension of the rope, and f of y equals t sine of theta. And we know also that f of x and the force of friction balance out, so there is no acceleration because the speed is constant. And we know that Fy plus n, the normal, holds up this block, and the weight pushes down on that, and there's no acceleration in the Y direction, and so that's also 0. So this is pretty much the way you set up the problem. Now there'll be some substitutions. The force of friction is equal to mu times the normal. And so the force of friction is equal to mu times the weight minus F of y. And so altogether, we end up with force in the x direction minus f of f equals tau cosine of theta. And from there, you can substitute in mu times w minus fy. And the problem then is set up. By the way, the coefficient of friction you should get is nominally, it's approximately 0.2. It will be different than that because the friction of the normal normal force caused by the friction is less than the weight itself. So I would suggest you all just go ahead and work out the total sum of all of the different steps that are on the document page 1. Thanks.